All right, we're moving on to direct variation, which is just a proportion. We're in lesson 8.1, and there are a couple ways to do this. I like to teach direct variation with y equals kx, where the k is the constant of variation. The reason number one being is that sometimes I see this constant of variation being asked, what is k? And you actually have to find it. Other reasons is because when we move to indirect variation, a lot of students start to get confused. I will show you the other way that you can line up direct variation because it is just a proportion and it's an easy proportion. But again, that indirect variation gets a little confusing. Our essential question today is, can you solve problems involving direct variation? And we will be able to do this when we end our time together today. It says if y varies directly as x. Well, I told you we're going to use this y equals kx. And y is 25. So I always tell my students we need two scenarios. The first scenario, y is 25 when x is 15. And then the next scenario says find x when y is 40. Well, let's focus on the first scenario first. I know that I have to divide each side by 15 to solve. So k is equal to 25 divided by 15. Both can reduce by 5, so we get 5/3. This k is called the constant of variation. So we're going to use the constant of variation to do the second part. Now it says to find x when y is 40. Well, I know y equals kx. This is my second scenario. Y is 40. My constant of variation, we solved it to be 5/3. Sorry, I just wanted to make sure it wasn't 3/5 and I was upside down here. 5/3. And now they're asking us to find x. So to get rid of this, I'm going to multiply each side by 3/5. And x is equal to 5 and 40 reduced to be 8. Looks like 8 times 3 is 24. So that's really all we're looking for. And again, we could set up a proportion and figure this out, but I like to show it using the constant of variation for that very reason, that people will ask you for the k, the constant of variation. Now, if you wanted to do it as a proportion, you could line up your y sub 1, your x sub 1. So I'm just going to show you how that would work. I would call this your y sub 1 and this your y sub 2. And because this is the first x, I would call that the x sub 1. So y sub 1 over x sub 1 is equal to y sub 2 over x sub 2. And it looks like we get 25x is equal to, well, 40 times 15 is 600. But let me show you something. So when I divide by 25, I do get the same thing as 24. So we get the same exact thing whether we use a proportion. But again, some questions are going to ask you for that little k, and you won't know how to do that if you do the proportion. While we're here, let me just show you a really cool way to simplify, because some of you guys still don't know this. Okay, we know we could simplify this way, but did you know you could simplify this way? So let's do that. I know that this can go divisible by 5, and so can the 15. But this 5 can also go into 40. And look at here, when I now cross multiply, I get x is equal to 24. And I wouldn't even have to use a calculator. So just take note of that. It does get very helpful to do that. All right, if a is directly proportional to b cubed, and a is 10 when b is 2. Well, again, I know this is my first scenario. A is 10 when b is 2. And it tells me my first scenario, a is directly proportional to b cubed. A is 10 when b is 2. Well, b cubed, wouldn't that be an 8? So when I divide by 8, My K, or my constant of variation, is 10 over 8, which reduces to 5/4. And then it says, my second scenario, find A when B is 4. Second scenario, well, we're looking for A now. I know my constant of variation was 5/4. And B is 4, but don't forget I have to cube that. So 4 cubed would give me that. So one of these will cancel out with one of these. So we have 16 times 5, which ends up being 80. All right, the last kind that you're going to get are these word problems. The amount of hydrogen produced when sodium is added to water varies directly as the amount of sodium added. I'm going to do that over here. So I have to make up my own y equals kx. The amount of hydrogen produced when sodium is added to water varies directly as the amount of sodium. So I called that H equals Ks. If 92 grams of sodium produces 4 grams of hydrogen, well, hydrogen, K, sodium is 92. When I divide, it looks like K gives me 1 over, 4 goes into 92, 23 times. So that is my first scenario. Then the second scenario says, find the amount of sodium needed to produce 10. Well, I need this to be 10, my H. I know 1 over 23 is my K, and I'm looking for S. So when I multiply each by the reciprocal times 23, you could probably do that in your head, you get S is equal to 230.